previous lesson we talked about the electric current intensity and we talked about the potential difference. It is almost related to our new lesson today, which is more interesting. So let us check a photo to know what we're going to talk about today. Okay, so anybody can tell me what is the difference between those two circuits? Yes, as you said, the difference is here in the position of the resistance. The first one, the resistance is side by side, so it is called the series circuit. And in the second one, the parallel circuit, the resistances are above each other. So for today, we're going to talk about Ohm's law. In Ohm's law, the potential difference is equal to the current intensity times the total resistance of the circuits. So let us begin with the series connection. In this series connection, we have three resistances that are connected side by side and a battery connected to a voltmeter to check the potential difference, an ammeter to check or to calculate the current intensity. So whenever the electric current intensity moves in this circuit, it passes through the R1, R2, R3. So it doesn't change. So we can say that it is constant. So the I total of this circuit is equal to the I1, equal to the I2, and also equal to the I3. However, the voltage is not constant. So the total voltage is equal to V1 plus V2 plus V3. And for the resistances, here how to calculate the total resistance? Yes, as you said, for sure we're going to bring the sum of those three resistances. So R1 plus R2 plus R3. The parallel connection. It is somehow different that the resistances are above each other. So let us draw this. Resistance 1, resistance 2, and resistance 3. Okay, connected to the voltmeter, connected to the battery, of course. Okay, so here we have R1, R2, and R3. So if we want to calculate the current intensity, we are going to follow the line of the battery. So here the electric current intensity moves in this wire. So it meets here. So what's going to happen? For sure it will split into the three resistances. So we have I1, I2, and I3. We move to the three resistance. Let's imagine that the resistance is lamps. Are lamps. So the lamp 1 and 2 and 3 should glow, so the current intensity should pass through those three lines. So here we have the I total of this parallel. I total is equal to I1 plus I2 plus I3. And here in this connection, the voltage is constant. So we have the V total is equal to V1 plus V2 plus V3. So to calculate the resistance here, it is different than the series connection. So the R total is the reciprocal of the R total. It's not the R total. So just remember this. The reciprocal of the R total, which is 1 over the R total, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So let us sum up this. Okay, we talked about the series connection and how to calculate the intensity, voltage, and the resistance. Here the intensity is constant, here the voltage is constant. We knew how to calculate this. Also we knew about Ohm's law. So what if we want to define Ohm's law? Here we have that the voltage is equal to intensity time multiplied by to the resistance. So here we have that the intensity is directly proportional to the voltage. So we can say that the current intensity in any conductor is directly proportional to the potential difference in any terminals at constant please on your copybook state the difference between the series connection and the parallel connection. Also please write the definition of Ohm's law. Regarding our homework for the next session, please solve the exercises in page 16 in the textbook. And thank you so much. Have a nice day.